Hello students, welcome to Shorsa's classes, and this video is on some basic concepts on atomic structure. I will try to give you a complete analytical background of this. And remember that before Bohrs model there were many developments. Okay, so before the Bohrs model, the terms related to atoms were like atomic number were there, mass number, there were isotopes, there were isobars, you know these things. So isotope was like atoms of the same element having different mass number, like 6c12 and 6c14. These were isotopes. Isobars, you know, that is, it is 6c14 and 7n14, these kind of stuff, which were different elements having the same mass number. There was isotones also. So in case of isotone, we have that 19K39 or maybe like 20Ca40. So these are having the same neutrons. So there are many basic types of structure. There was iso stars. So where species having same number of atoms and electrons are isostars, like N2, CO, this kind of stars. Now, Rutherford nuclear model was a little bit different. So, the Rutherford's model is in the Rutherford model of atom, Rutherford performed an alpha particle, that is helium-2 plus, scattering experiment on a thin gold foil. And he presented that most part of the atom is empty, Second, every atom possesses highly dense and positively charged centers, which is called nucleus, and entire mass of the atom is centered inside the nucleus. And Rutherford later was also abandoned the model because due to the failure to comply with classical theory of electromagnetic radiation. So the theory also fails to explain the line spectrum of H atom. So they didn't explain the line spectrum and electromagnetic radiation structure. Now later I will go to another important part in the atomic structure, which is called the Planck's equation. In the Planck's equation, the pattern was E equal to hv, and which was hc by lambda, where h was 6.625 into 10 to the power minus 34. Okay, later another important concept came into way, that is called black body radiation. So radiation by a black body, you can take this board as the black body over here. So it's an ideal and identical body that emits and absorbs radiation of all frequencies, then it's called a black body, and it can be explained by the Planck's quantum theory. So there is a photoelectric effect also comes into this progress. So what is a photoelectric effect? In the photoelectric effect, when light of frequency more than threshold frequency, the threshold frequency is V0. So when the light frequency is more than this threshold frequency, strikes a metal surface, it ejects electron. So it ejects electrons. So this phenomenon, the entire ejection of electron from the threshold of a metallic surface is called a photoelectric effect. It is half into V square equal to hv minus is V0 V minus V0. So this is the stuff where V is the frequency of the light and V0 is the threshold frequency, and H, as I have already written before, H is Planck constant, which is 6.625 into 10 to the power minus 34. So alternatively it is half into mc v square equal to hc 1 by lambda minus 1 by lambda 0. Later, now I will go to different modeling which is called Bohrs model. So Bohrs proposed an ideal stationary orbit in which electron revolves. So according to Bohrs model, electron does not lose energy as long as it stays in an stationary orbit. Now when the electron jumps to lower stationary orbit, so energy is lost in the form of electromagnetic radiation. So conversely, when energy is supplied, so electron jumps to higher stationary orbit. So according to Bohrs model, angular momentum of an electron is quantized as the angular momentum, or MVR, is nh by 2 pi, where n equal to 1 to ... infinity. So this is, n is nothing but, if you are wondering what is n is the orbit number, h equal to Planck constant, pi is only pi. So Bohr's radius, if they ask you in some cases, Bohr's radius, so using the relationship which has been done before, and one part I missed out. So if there are centrifugal force of orbiting electron is exactly balanced by the electrostatic attraction between nucleus and electron, so in that case it is mv square by r and ze square by 4 pi epsilon 0 r square. So this is a pattern. So in the Bohr's radius, as I was talking about, so Bohr's radius using the above two, this is this and this, we can say that r of n is a0 n square z. So where a0 is nothing but 0.529, I am struck first Bohr radius. Okay, so this is the part. Next is speed of electron in the nth Bohr's orbit. Speed of electron in nth Bohr orbit. So in that case it is 2.18 into 10 to the power 6 meter per second. So number of revolutions made by electron in the nth Bohr orbit is the revolution per second. So that is Vn here. Vn is the, so revolution per second, if I ask, Vn by 2 pi Rn. So Vn is the speed of the nth orbit.